Welcome to another video. This video is introduction to trees. Okay, so this is one of the most important topics in data structures. Let us dive quickly into this topic. First of all, trees a hierarchical data structure, right? Hierarchical data structure. Hierarchy is most important here because normally when we have seen linked list or arrays and linked list were linear in nature, right? Stacks and queues were also linear in nature, right? Linked list, for example, we had something like head, and we had linked list, right? Data part as well as the uh, pointer part, right? 200, right? Something like this. 40 null, right? And this is something like 100, right? This is a linked list, right? Linked list is linear in nature, linear, one after the another, whereas tree is hierarchical in nature, is a hierarchical data structure. For example, as we can look at this tree, you know, this is the first level, this is the 0th level, this is the first level, and this is the second level. Trees are basically hierarchical in nature, which means that they are non-linear data structure. A tree is a non-linear data structure, right? So the most important point is that there are levels to trees. This is the 0th level, this is the first level, and this is the second level, and actually this is the third level. Here we have 4 levels: 0, 1, 2 and 3, right? For example, you can take A as a director of a company, right? Then you have B and C, they are presidents of a company, and here you have D, E, F, G, they are vice presidents of a company, and H and I, they are managers of a company, right? So here there are various levels in trees, and trees are hierarchical in nature. Let us look at now some important terminologies of a tree, right? So first, before going to terminologies of a tree, I would like to say that these terminologies are very important for competitive examination. Some simple questions might be asked based on these terminologies, right? For example, the first terminology is a node. What is a node? A node is a basic element that contains data. For example, a is a node, right? So this is just a logical representation. A might contain some data like 10, 20, 30. So every node, I am representing node with the letters, but node can contain data like 10, 20, 30, 40, right? Anything. Node is a basic element that contains data. Here A is a node, B is a node, C, D, E, F, G, H, I, J. All these are nodes in this example tree. All these are nodes, right? What is a root node then? The topmost node, which is the starting point of a tree. Here the root node is A. In our example, the root node is A, right? A, and a tree has only one root. So in this example, the root node is A. What is an edge? An edge is a link between two nodes. For example, here as you can see, this is an edge between A and B. This is an edge between B and E. This is an edge between E and I. Therefore, here a link is nothing but edge is nothing but a link between two nodes, right? Parent node, a node that has one or more children. Here we can see A has 3 children, B, C and D. Therefore, A is called a parent node, a node that has one or more children. So I can say A is a parent, right? I can also say B is a parent because B is a parent for E and F, right? It has 2 child nodes, E and F. Therefore, B is also a parent node. C is a parent of G, right? So G is a child node of C. Therefore, C is also a parent node. D is also a parent node because it has one child node called H, right? E is also a parent node because it has 2 child nodes I and J, right? So here in this example, A is a parent node, B is a parent node, C D, right, and E. These are all parent nodes. These are all parent nodes. And what is a child node? A node that is a descendant of another node. Here we can see B is a child node because it is a descendant of A. C is a child node because it is descendant of A, and D is also a child node because it is descendant of A. So I can say B, C, D are all child nodes which are descendants of the same parent node called A. Now E is also a child node because it is a descendant of B. F is a child node because it is a descendant of B. G is a child node because it is descendant of C. H is also a child node because it is descendant of D. And I descendant of E, and J descendant of E. Right? So these are all child nodes. Now what is a leaf node? A node with no children. As we can see clearly here, G does not have any child node. H does not have any child node. F does not have any child nodes. I does not have any child node, and J does not have any child node. So in this example, F, G, H, I, and J, they are all leaf nodes. A node, if a node does not have any child node, it is nothing but a leaf node. What are internal nodes? A node that has at least one child, right? So for example, A is a child node, A is an internal node because it has 3 child nodes, B, C, and D. So I can say A is an internal node, right? B is also an internal node because it has 2 child nodes, E and F. C is an internal node because it has 1 child node, G. D is also an internal node because it has 1 child node, H. And E is also an internal node because it has 2 child nodes, I and J. Therefore the definition is a node that has at least one child, at least minimum of 1 child. So all these A, B, C, D, E have minimum of 1 child. So we can also say all nodes except the leaf nodes are nothing but internal nodes, right? So we can also say here, I just write here, all nodes except leaf nodes, right, are internal nodes, yeah. So as you can see here, all of these are the nodes except the A, B, C, D are nodes except the leaf nodes. Therefore all nodes except leaf nodes are nothing but internal nodes. Siblings, nodes having the same parent, right? So I can say here B, C, and D have the same parent A. Therefore I can say B, C, D are siblings, right? Here E and F are also siblings because they have the same parent B, right? So I, J are siblings because they have the same parent E, right? Ancestor, any node that lies on the path from root to that given node. For example, if I take E, what are the ancestors of E? Okay, ancestor. What are the ancestors of E, right? So the definition says any node that lies on the path from root to that given node. So here there is only one path to E, right? A to B and B to E, right? A to B and B to E, right? So A and B are called ancestors of E. So A and B, right? Ancestors of E are A and B. Why? Because A and B lie on the path from the root to E, correct? So what are the ancestors of F? Ancestors of F are also A and B, correct? Because A and B lie on the path from root to F, right? Let us look at G. What are the ancestors of G? A and C, right? We can say for C they are nothing but A and C, right? What are the ancestors of I? Okay, for ancestors of I can say A, B, E. A, B, E are ancestors of I, right? Descendant, any node below a given node in the tree hierarchy. Any node below a given node in the tree hierarchy. So what are descendants of B? Descendants of B, I'll just write here. Descendants of B are any node below a given node in the tree hierarchy. So descendants of B are E, F, I and J, right? So any node that is below the given node, so any node below, so F is below B, so it is also a descendant of B. E is below B, therefore E is also a descendant of B. Okay, I is also a descendant of B because it is below the node called B, right? And J is also a descendant of B. So I can say here E, okay, I, J, F are all descendants of B, right? Are all descendants of B. What are the descendants of C then? The descendant of C is only one, G, right? So descendants of C is only G, correct? Only C. What are the descendants of A? What are the descendants of A? C and G, right? The descendants of A are also C and G. They are, and descendants of A is also are also B, E, okay, F, I, J. So descendants of A are actually all the nodes of A, all the nodes which come below A. Therefore, descendants of the root node are all the nodes in a tree except the root node, right? So descendants of A are all the nodes in the tree except the root node. So we will not count the root node. Descendants of A are all the nodes except the root node. So I can just say, I'll just erase this one. I can say descendants of A are all nodes in a tree except root node itself. Degree of a node, number of children a node has. So what is the degree of A? Degree of A has 3 children, therefore I can say 3. What is the degree of B? B has 2 children, I can say 2. Degree of C, 1. Degree of D, 1. Degree of E, 2. Right? What is the degree of a tree? The maximum degree of all nodes of a tree. So as we can see here, we have got the degree of each and every node in this tree. Therefore here maximum is nothing but 3. Therefore I can say degree of a tree is 3. In this example, degree of a tree here, degree of tree is nothing but 3, right? So A has 3 children, B has 2, C has 1, D has 1 and E has 2. Therefore degree of this tree is the maximum number of children, the maximum degree of all nodes. Here we can see A has 3 children, therefore degree of a tree is 3. Level of a tree, distance from the root node. Basically here I can say here this is level 0, this is level 1, this is level 2 and level 3, right? Level 3. So here the distance from the root node, the level of a tree here, right? So I can say the level of this tree is 3. In fact there are 4 levels, right? So I can say here 4 here, right? I can say 4. I can also count from, I am saying here 0, but I can also say here 1, 2, 3 and 4. 1, 2, 3 and 4. So it would be 4. The level of this tree is 4. Height of a node, the number of edges from the longest path from that node to the leaf node. So if I want to find the height of B, right? Height of B, the number of edges from the longest path. Here B has many paths here. Here B has B, E, I. So longest path from the node to the leaf node. From this node to the leaf node, right? So there are various leaf nodes here. F is there here, I is there and J is there, but we need to find out the longest path. So here I say B to E and E to I, height is 2 because it has two edges, right? 1, 2. So it has 2, height is 2 here. B to E and E to J, it has two edges, right? So height is 2. And for B to F, it has only one edge, therefore height is 1. So height of a node is the longest path. The longest path is 2, therefore I can say height of B is 2. Height of B is 2, right? Now, what is the height of a tree? Height of a tree is nothing but the height of the root node. Height of the root node. So what is the height of the root node here? So how many number of edges here? So I can say here A, B, E and I. So I have three edges, therefore height is 3. A, B, E, J. 3 edges, height is 3. A, B, F, height is 2. A, C, G, height is 2. A, D, H, height is 2. Therefore, height of the root node is the longest path from the root node to the leaf node, right? So height of a node is the longest path from that node to the leaf node. Therefore, height of a tree is the longest path from the root node to the leaf node. The longest path from the root node to the leaf node is nothing but here, as we can see clearly, 3, right? 3. Therefore, the answer is here 3. Height of a tree is 3. So what is the depth of a node? The depth of a node is nothing but the distance from the root node to that node. For example, depth of E. Let us find the depth of E here, right? So depth of E, for E, the depth of E is nothing but the distance from the root node to E. For example, number of edges are A to B and B to E, right? So A to B and B to E. So number of edges are 2, right? Therefore, the depth of E is nothing but 2, right? What is the depth of G? Depth of G is nothing but A to C and C to G. That's nothing but 2, right? What is the depth of D? Depth of D is just A to D. Therefore, it is 1. So we can also say the depth of a tree. Here we have seen the depth of a node, but the depth of a tree is nothing but the distance from the root node to the leaf node. Distance from the root node to the leaf node. The distance from the root node to the leaf node, or the maximum distance from the root node to the leaf node, is nothing but the height of the tree. So here I can just say here the height of a tree equal to depth of a tree. Height of a tree equal to depth of a tree. Please understand that height of a node might or might not be equal to the depth of a node, right? But the height of a tree will always be equal to the depth of a tree. For example, here let us take B. The height of B is nothing but B to E and E to I, right? B to E and E to I. So 2 edges. So height of B is 2. So, right? So B to E and E to I, it is also B to E and E to J, 2, and B to F also. So the largest path is B to E and E to I, and B to E and E to J, 2. Therefore, the height of B is 2. Height of B is 2. Whereas the depth of B is nothing but A to B, one edge. So the depth of B is 1. Therefore, here height is 2, whereas depth equal to 1 for B. Therefore, the height of a tree is equal to the depth of a tree, whereas the height of a node might or might not be equal to the depth of the node, right? Might or might not be equal to the depth of the node. For example, as I'll just write it up a little here. Well, let us take the height of C. Height of C is nothing but C to D, that is 1, right? And the depth of C is nothing but A to C, that is 1. Therefore, height is 1. Therefore, here height equal to 1 and depth equal to 1. Both are equal. Therefore, here for this example, for C, height and depth are equal. For B, height and depth are not equal, right? But for the whole tree itself, height is always equal to the depth of a tree, right? Subtree, any child node along with its descendants. So for example, B is a child of A, is a child node of A. Therefore, what is a subtree? Any child node. Therefore, here this whole thing, right? B along with its descendants are nothing but the subtree of A. Subtree of A. B along with its descendants, B along with E, F, I and J are nothing but a subtree of A. So C and G is a subtree of A. D and H is a subtree of A, right? So here we have 3 subtrees, right? Here we have 3 subtrees, right? So not only for the root node. So here, not only for the root node, let us take the example of B. For B, EIJ, is a subtree of B. F is a subtree of B. G is a subtree of C. H is a subtree of D, right? So not only for the root node, for other nodes as well, you can have subtrees. For example, here again, for B, subtree of B is nothing but E, I and J, right? So these are some of the terminologies of a tree which we have seen. This will be useful for competitive examinations. For example, I have already told you that the height of a tree is always equal to the depth of a tree, whereas the height of a node might or might not be equal to the depth of a node. So these kind of questions might come in competitive examinations. Thank you for watching.